In this video, we're going to look at whether to use the sine or the cosine rule dependent on what information is given in the question. In this first example, I actually want to take us back a step and make the assessment as to whether we should be using sine or cosine rule. Because I've got a 90-degree angle, I would actually use neither in this case, and I'd revert back to using our very basic SOHCAHTOA relationships, or indeed Pythagoras as another option. In the question that I've set myself here, I've got the opposite side to the angle 34. If I wanted to find QR, I could use sine is opposite over hypotenuse, or if I wanted to find the adjacent side QP, I could use tan. In this question, I clearly don't have a 90-degree angle, so it is sine or cosine rule. And the thing to always look out for is whether you have a side angle opposite pair. Here I know the 30 degrees and I know the length opposite it, RP, is 5 meters. And that tells me then I can use the sine rule. There are two versions of the sine rule. They're really the same thing, just the other way up, but because it's a ratio, that's fine. I would always use the version that has the unknown quantity on the top. So in this particular question, we might be trying to find angle P, so I'd be using the second version here with the sines of the angle on the top. There is one case where looking for side angle opposite pairs can go a little wrong. If you've got a side angle opposite pair, it is the sine rule. Now this type of question often catches candidates out because on the face of it, there isn't a side angle opposite pair. But actually, if you know two angles in a triangle, 38 and 76, we know they add up to 114, so therefore angle at R must in fact be 66. And as soon as I've got that, I actually do have a side angle opposite pair. So this one again is a sine rule question. In this next example, I don't have a side angle opposite pair, and I don't have any way to find any of the missing angles. What I do have is this side angle side relationship, or SAS, and if you have that, that suggests you can use the cosine rule. Cosine rule is given on the formula sheet, so you don't actually need to learn it, although you'll pick it up as you practice this. The only thing to be careful of is how you name the sides. So because we know that the angle of P is 70 degrees, that needs to be our angle A, and that means the unknown length here would be our side A. The B and the C can be your 5 and your 16, and the order there doesn't matter. In this one, again, we don't have any angles, so clearly no way to find the missing angles, so no side angle opposite pair. So again, it has to be the cosine rule. If you've got three sides, you can find any of the angles, again using the cosine rule. Just make sure again you make the angle that you're trying to find your angle A. So if we were trying to find Q, that would be angle A, side A would be the 5, the 11 and the 16 can be B and C, and that order doesn't matter. If we look at all the problems we've considered in this video, you'll sort of see a pattern that emerges in that I always need to know three pieces of information. The one that you might be thinking you don't have is here. Well, actually you do, because this angle is 90 degrees. So we do know three pieces of information in all these triangles. And knowing that, we can then find all the other missing information. There's one circumstance where that goes wrong, and that's here. If you know three angles and no sides, that causes you a problem in that with three angles, I can have an infinite number of triangles, just different sizes, that have three angles. And in this situation, there's actually absolutely nothing I can do.